Hello everyone, welcome to It's Electrifying, powering our buildings without fossil fuels. The learning objectives for this session will be shown in 1 second. There they are. And we'll be following up with a survey and with more information on how to receive credit from AIA for this session. We'll also collect questions submitted to the Q&A box throughout the session. And if our speaker isn't able to get to all of your questions, we'll have her answer them in writing and share her answers on the website after the teach-in. Now, it is my pleasure to introduce the speaker for this session, Claire McKenna. Claire is a senior associate at Rocky Mountain Institute, where she researches the techno-economic case for building electrification in the US. By developing tools to advance knowledge and fostering collaborations across industry, municipalities, and utilities, Claire supports RMI's goal to eliminate the use of fossil fuels in buildings by 2045. Welcome, Claire. Thanks for joining. So Claire, if you would like to share your screen now, then you are free to dive in.
Let's do it. Okay, so welcome everyone. It's really exciting to have the opportunity to share this story with you. I come from 10 years in the building industry, and so now so I get to kind of work on this from a research angle and kind of get to relay back to the building industry from the context of that deep knowledge, you know, what the future holds for us. So we're going to run through this agenda. We've already done the poll in the intro, so we're going to move on to regional considerations and just start with a summary of what building electrification is. So I put this slide up here. Basically, these are all of the kind of climate-aligned science targets for building electrification. You know, this can seem a little bit abstract, but for those of you who speak the language, I wanted to make sure that you understand that a gigaton savings, particularly for North America, is kind of what the opportunity is as Rocky Mountain Institute sees it. That means that 70 million buildings in the US alone need to convert to all electric away from fossil fuels. And this gets us to the 1.5 degrees C, you know, target by 2050. So just wanted to make sure that kind of outline is there for you, but at the same time, you know, as we talk about the technology, as we roll through the next half hour or so, just make sure that you realize that it's an incredibly disruptive market transformation that's currently in the very early seeding stages, and from a deeply transitional perspective, this is kind of what we're looking at. So this is again the emissions graph, and this is the notion that I think what really stands out for me here is just the precipitous fall of emissions, and again the underlying context of what actually needs to happen to accomplish that. That's what we're going to explore today. So regional considerations. When we talk about building electrification, we are talking most specifically about heating climates, and then the different components of basically whether electrification is truly an environmentally sound or you know, reasonable approach. That has to do a lot with the severity of the heating climate, like how much heating is actually required, and then also what the grid or fuel mix is and what regional energy sources are available. Cooling climates really are not as much the focus of this. So folks tuning in from South America, you know that if you don't have heating, heating needs, spacing needs on an annual basis, then you know, this is not really the concentration here. So when we're talking about electrification, cooking and heating are really the areas of focus that we talk about when we're talking about fuel switching or technology transformation. So this is some results from a recent study that I did with my group here at the Building Electrification team at Rocky Mountain Institute. Essentially what we're trying to show here is that there are, as I mentioned, there are two components to whether electrification is a sound environmental strategy, meaning when we look at it on an annual basis, will converting to electric heating actually reduce carbon over the status quo or maintaining a fossil fuel combustion system for heating. And there are two components, as I mentioned. So Annual heating coefficient of performance, or COP, is kind of what we look at from an engineering perspective on how efficient is the heating when we move to this heat pump technology. So just to clarify, we're talking about heat pumps as opposed to electric resistance heating. And this is really what RMI and folks that are working on electrification are advocating for when we talk about fuel switching to electrification. We're going to use the benefit of the heat pump technology, which actually gets well above 2, a lot of times 3 times more efficient in heating than let's say a natural gas boiler, which can be anywhere from 80% to 90% efficient. So we're getting that really important efficiency delta. And that's kind of represented here for some of the more severe climates in the US. So, you know, a lot of these are the northern, either more mountainous or more snowy and wintry cities. And then we also compare to Los Angeles, saying that for any heating that needs to happen in Los Angeles, a climate may be more similar to the southern part of South America. We're looking at COP of 4. And then the other side of that environmental balance is whether or not the grid is actually green enough to kind of offset that savings. And so for continental United States, we found that only 2 states were really on the margin. Every other state in dark blue here has a grid emissions low enough, from a future perspective, to actually make the switch to heat pumps net zero or actual carbon savings over the status quo today. I wanted to highlight some of the more cooling dominated countries in South America and talk about the fuel mixes there. So this is from an MIT study that was done in 2018, looking at the grid fuel transitions for every country in South America, but really wanting to highlight Chile and Argentina today. So you can see that the mix is actually interestingly different. So in Chile, there's a pretty significant coal baseline that's projected to come down a bit to 2030. But the fact that there's so much coal on the grid right now is actually going to have pretty significant implications for whether or not the conversion to heat pumps makes sense from an environmental perspective. And I would imagine this is more similar to Colorado, which is actually where I'm currently located, where we do have a lot of coal in the grid mix, and that's actually what's holding back. This is Colorado, that's Wyoming, sorry. Colorado and Wyoming have a lot of coal, and that's actually what's holding back these states from breaking even. Argentina has a lot of natural gas, but seeing the oil come down and an increase in nuclear and other emissions-free resources. So that's kind of some of the important things to look at. And just one more note here, that it's really important to look at the future, where the grid is going, rather than like a backward-looking or even a current-looking assessment of what the grid scenario is today. So moving on. District thermal heating is kind of like another way we think about electrification. So this is kind of the concept that that there would be a thermal heating distribution network. And I like this idea, you know, in comparison to individual building electrification with heat pumps, because I think that this kind of represents a more viable transitional way, especially areas where we see a lot of natural gas infrastructure. Okay, if you guys can't hear me or something, just let me know. I see some notifications, but I can't see what they are. So the thermal distribution network, I think, is a more viable kind of like systemic transformation from the grid, the natural gas infrastructure that we have today. And from that perspective, actually provides potentially a easier transition to a more equitable energy resource for more people, rather than thinking that we could convert each individual home to electric heat pumps. That kind of, given the society and the structures that we have today, kind of tends to lend itself towards, you know, skewing towards more affluent communities first, and it's hard to account for a more equitable distribution of the technology. Just quickly, on a global look, the carbon intensity of district heating systems basically means how is the thermal loop, like how is the hot water on the thermal loop actually heated. So most of us know that in Iceland, these are kind of the poster children for geothermal. They have lots and lots and lots of geothermal. That's why they're so famous for their hot, hot springs and hot soaking pools. But then other areas of the world, maybe heating with fossil fuels, and so we're on a proportion here. And so in order to get to the electrification, the carbon-free electrification that we're looking for, we really want to be on the higher end of a fossil fuel-free energy supply for the district heating system. Okay, moving on to universal considerations. So there I tried to break down basically the notion that not every place is created equal in terms of its environmental opportunity. But when it comes down to air quality, this is something that all of our regions should be very concerned about. This recent research from the California Air Resources Board and some researchers in California found recently that direct combustion of fossil fuels in buildings, mostly related to, like we said, space heating and water heating, has almost as much outdoor air pollution contribution, particulates, this is specifically NOx, nitrogen oxides, so has almost as much air pollution contribution as all light-duty vehicles in the state. And so I think when I saw this comparison, it just completely floored me. Kind of in the background here is kind of the prototypical smog problem in LA. And so when you think about how buildings, direct combustion of buildings, actually flying under the radar of like public knowledge on what air quality, poor air quality contributions this fossil fuel combustion in buildings has, it starts to really awaken us to understand how pressing this is, and how quickly it'll start to change once this information becomes a little bit more available, like the research can kind of come into the public eye. Equally as surprising, the indoor NO2 or NOx emissions from cooking on a gas range can actually exceed the outdoor air, basically outdoor air quality requirements that the EPA, the U.S. Environmental Protection Agency, has for outdoor air. So currently in the United States, indoor air quality is not regulated, but we're finding through similar research here and actually some novel research that my team has done and presented in May. This is something you can find on our website, and I'm actually going to be able to provide the slides, so you should be able to access this too. And I highly recommend that you kind of dive a little bit deeper into this and educate yourselves on how under the radar but yet how alarming the indoor air quality from gas stoves emissions actually is. Moving on, so this is another topic that wherever we are in the world, is something that we kind of need to know a little bit more about. So this is the idea that induction cooking technology is going to be replacing gas burners. So this is kind of like our solution to the indoor air quality problem. And here we have a comparison for those of us who love graphs and think about energy and basically, excess energy is being wasted. And certainly we need to continue an efficiency mindset as we think about the transformation to electric buildings. What's happening here is we have a couple of different induction cooking ranges, the red lines here. So what happens is when induction turns on, it's going to heat through an electric coil. It's going to directly heat the pan, and so there isn't this electric resistance which kind of heats up that kind of works the same way as a space heater does. Actually, electric resistance heater or electric resistance coil here is going to actually provide way more energy, and that's everything you see here above the boiling line that is actually needed to directly heat the water, which is what the induction technology actually enables, and why we think that that's really important, and again, kind of understood technology that's going to really, that this transition is going to kind of ride on the back of. So I don't know, this is photos of my team. We got together in February before the pandemic and cooked together just to test out the technology. So I could say it works. I can't vouch for the fact that it's completely affordable right now, but that's something we'll have to watch for, and something I certainly advocate for folks to kind of, again, educate themselves on. Lastly, on the universal considerations, refrigerants, you know, are a known issue. And so when I talked about the environmental trade-offs of basically the heating efficiency and the grid emissions, that didn't actually account for refrigerants. Although I've seen some studies coming out of California that said the conversion actually pays back within a year, and so we need to continue developing and implementing this heat pump technology, even though we know that refrigerants are not exactly where we need them to be. But I did want to outline kind of like where refrigerants have come in their stages of development. So, you know, before the widespread adoption of HVAC in 1920, we didn't have refrigerants. I'll jump to basically 80s and 90s, Montreal Protocol, Clean Air Act, which started to look at what was being used at the time and transitioned to actually R410A, which is what is widely used today. But that has, although it does not ozone depleting, it does still have a high global warming potential. And so as of 2016, the Kigali amendment to the Montreal Protocol, kind of an updating, there was a global consensus that there's a need for transition to lower global warming potential refrigerants. The problem with those right now are that they are largely flammable, and therefore, at least in the US, and I think this is true for most of the world, the building codes, especially the fire code, really limits how much of these refrigerants can be in the building. And that makes sense from a public safety perspective. But kind of trying to align around, you know, one of the biggest transitions, you know, that will have to happen to actually enable electrification with the use of heat pumps is to get a better grip on what refrigerants can be used and how can we work with the laws that we have to deploy those safely. And so just in summary, I think, you know, how do we think about refrigerants? This is one of the biggest issues really of everything I presented. I think, you know, induction cooking doesn't come close to the impact that refrigerants actually have for this transition. And I think we're at the place right now, unfortunately, where there isn't something that really comprehensive that can be said about, oh, this is the one definitely to choose and let's all move in this direction. I think, you know, the US is in a place, the EU is in a different place relative to what's allowed. Again, all of it comes down to public safety laws. And so what I'm advocating for here is basically they're really, I think, the latter two main areas of focus that we want to encourage use of low global warming potential refrigerants, and that's kind of how I mentioned looking at policy and kind of develop R&D to develop new refrigerants that are going to make more sense. And then also looking at how the HVAC systems actually cause, like, leaks are inherent in those systems, and how we can kind of tool our systems that we create moving forward, even if they're the kind of standard, you know, refrigerant-based VRF systems, to actually leak less. And so a lot of that is going to be maintenance, leak detection, which is not something that's done in a widespread manner today, or controlled for from an environmental perspective. So anyway, these are my my recommendations for how we can get ourselves out of the refrigerant quandary. Okay, so moving on to quite a bit of a chunk on existing building electrification. So when we talk about you know, 70 million buildings in the continental US that need to transition to electric, that's the biggest chunk of the pie, I think, where us as industry professionals really need to focus our energy. And I think that from a kind of a fortune telling perspective, this is a market that's coming up. I think, you know, it's not as big as the construction industry today. I think we're not really focused on retrofits, but as we move towards mandating, politically mandating electrification and greenhouse gas emission savings, we will need to be looking at retrofits more seriously. And so I think that there is a new market coming in this regard. I'm going to kind of take you through some of the foretelling trends and projects that are coming up in Europe, actually, that I think are really good models. So basically what we need to do is transition from kind of a status quo, like project-specific craftsmanship-oriented retrofit model that we have currently in much of the world, and transition to industrial production of retrofit panels and retrofit solutions. So Energy Sprung is a really, really cool, I guess it's like partly a movement, partly an organization that has sort of figured out like a comprehensive way to retrofit multifamily housing to be both all electric and have a better envelope performance, so better efficiency, and it also includes solar. I put this little snapshot from their video online. I think they've just updated their online resources, and again, I highly recommend that you go to energysprung.org because it's a really cool explanation of kind of what they're proposing, and I think does a good job at being like sort of a cultural force and this is something that really interests me, like how does the cultural force tie into these technical changes, because so much of it is, you know, when we talk about multifamily development, what people need to buy into, right? It becomes like a market issue. Okay. So what are the technical components of Energy Sprung? And also, as you'll see, what we're starting to do through RMI in the US. So unitized facade panels. This is industrially prefabricated facade panels that actually go directly out onto the outside of the existing multifamily walls, which is super cool. Mechanical system pods that are inherently all electrics, so designed to be you know, completely fossil fuel combustion free and also modular. And then energy plan financing, which is sort of the enabling component, I think, of this. The technology is hugely important, but again, to make this the societal change that we need to see and the level of affordability that is actually extremely important from an equity perspective, we need to think about the financing. I'm not going to touch on that as much today. But for those of you who love buildings and are here to hear about the technology approaches, there are some 3 kind of major prefabricated manufacturers in the Netherlands. I forgot to mention, Energy Sprung is a Dutch initiative. And I think it's starting to include sort of more EU countries, but really does originate from the Netherlands. And these are some of the companies. My teammates from RMI actually visited the RC panel factory floor, and so these are images from their visit there. So that was cool. So then when we talk about facade installation, and I think I'm going to outline what the actual envelope performance criteria are in a minute when we talk more about this, the US case studies. But the facade installation has a little bit of site pre-work here, and you're kind of seeing that, like laying out the frames and laying out the kind of the junction points, and that's actually kept to a minimum, and that's the whole concept of having this industrialized prefabricated solution. So then moving to the mechanical pods, the modular mechanical pods, there's another partner on board called Factory Zero, also based in the Netherlands. That's a mechanical HVAC, basically fabricator. And they came up with this concept of putting all of the domestic hot water, the HVAC, and the PV inverter, and the energy recovery ventilator. So everything required to kind of make this house run all in one place. And so and you can see it's kind of cool. It's almost like what you would put onto a spaceship in a way. Like it has to be packaged so that it can just sort of be dropped on. I think that this is the really cool innovation here, is definitely not in the technology. Like we know that the PV inverter is going to be off the shelf, the RV is off the shelf, but when it comes together and is packaged here and sold as a product, I think that's the real interesting innovation. So here are some examples of what that module looks like in real life, and then here's kind of how it gets positioned outside of the project. I think it's pretty standard. I mean, it's not going to floor you with its attractive beauty, but in the end, this is kind of the first run at it. And then here's the finished project, and super cool that it also has solar on top. Again, this is the case study from the Netherlands. I found this really fascinating. Basically, the supply and demand sides of the market here sort of work together to negotiate a price reduction curve. And I can't see what's going on here on the right, but this is sort of the model that the U.S. projects are looking at when they you know, think about affordability and targeting that kind of like financing as well, because you know, if the market, both the demand side, the customers, and the supply side, the manufacturers can kind of know where the market is headed, it gives everybody a lot more confidence in how to step into this. And I think that's really needed to kind of, you know, kickstart this this just transformative new product. So Realize is the name of the project that kind of takes up the energy sprung inspiration and guiding principles and applies it into the U.S. So here we're using a passive house U.S. targets for efficiency. So that's going to drive the envelope performance. Really targeting zero emissions, operational emissions, and with an aspirational goal of having a reduced embodied carbon. So hopefully you're tuning into sessions about that. We're not going to cover that here today. And then essentially simplify the retrofit process. So really, you know, leveraging the inspiration from Energy Sprung and thinking about how manufactured wall panels and modular HVAC can make a huge difference in kind of the scale of retrofits for multifamily in the U.S. There are two examples. We're going to touch on Beverly Terrace. Beverly Terrace is located in California, so not really an extreme heating climate, but in the end, I think a really important case study. And so you can see that I'm not going to go into this too much because I do want to make it to questions at the end, but basically wanted to point out that the typologies here, like one of the biggest challenges is for any group, an organization or a contractor or a manufacturer to try to actually deploy this at scale, even though the industrialization of the products really helps. Understanding what the typologies are for the conversions, basically like what HVAC, this is just one example of the HVAC system typology or the heating system typologies, but for all these different, if you can see San Francisco, Oakland, San Jose, Sacramento, Fresno, Los Angeles, Napa, San Diego, those are all representative of different cities in California and actually have quite a diverse climate as well. So those farther south, like San Diego and Los Angeles, are going to be super, super hot, but also on the ocean. And then San Francisco is, you know, notoriously pretty chilly, although doesn't have a severe heating climate. And even within that context, there's quite a range of heating typologies. And so this is something that the industry is going to have to tackle, is just getting more aware of what those differences are. Oh, I thought I had some recommendations, but yeah, that's my recommendation, is that that we think about this from a holistic perspective. Like if we're gonna, depending on who you are as a solution provider, like are you a government or are you, you know, researching this or providing it on a technology basis. I think kind of cracking this, what are the typologies in my area and how can I address those? Either address the biggest section of the market or maybe specialize in being flexible. I think that would be what I would recommend in terms of how we position ourselves to really make this change happen effectively. Okay, so about 5 minutes here, I'm gonna cover new building electrification. This is actually more my area of concentration. So I want to set the context a little bit for what new building electrification is looking like, again, in the US right now. There are 3 cities in the US, interestingly, geographically far apart. So Berkeley, California, again, on the West Coast, Brookline, which is actually a suburb of Boston on the East Coast, and then Tacoma Park, which is a suburb of Washington, DC, our capital, have all kind of taken the initiative to ban the use of fossil fuels in their cities. And so this is pretty unprecedented. Berkeley, California was the first. This happened last July, so just over a year ago now. It's pretty unprecedented from the perspective of typically the states in the US have the jurisdiction of the building codes that say what is and is not built in buildings. But these cities said, to hell with that. You know, we don't want to see any more fossil fuel combustion, in particular natural gas, in our buildings for new construction. And so it's been a really exciting trend or like first mover kind of initiative that RMI is taking up. So my team in particular, and my job specifically, is to work with Brookline in Massachusetts to we're currently running a program called the Building Electrification Accelerator that actually extends the know-how, the expertise, the kind of like peer learning platform for banning natural gas and fossil fuel combustion in new buildings to 13 other cities in the state. And so we're trying to basically amplify this this movement and make sure that that state representatives and even the federal government are aware of how important it is to basically stop digging the hole of continually investing in the fossil fuel infrastructure. So here is a summary of where this kind of new fossil fuel prohibition, new construction is happening. So as I mentioned, Brookline and Berkeley were kind of the first. That happened last year and the beginning of this year, 12 plus other cities and towns. That's my program at Mass. And then in Denver, Colorado, other cities in Colorado are working on a similar mission. Boston itself, is just kind of just geographical, but is sort of taking another tack. So instead of directly prohibiting fossil fuel combustion, are sort of like mandating the assessment of all electric solutions from developers. And so saying, if you want to develop, a multifamily building or a master plan in Boston, you have to prove to us why you can't do an all electric building. So I've worked in that space on the developer side as an engineer, and just was pretty floored at that movement. And so I would expect that folks around the world might be seeing this in planning as well. And then lastly, Seattle, just because of the laws, is sort of taking a different tact. So looking at local code amendments to incentivize electric buildings, saying that like if you make an electric building as opposed to a gas building, we'll give you more FAR. You can build, there'll be a more easy negotiation on like trans-oriented development. And so, I don't know, it's tough to think about trade-offs and sustainability, or like what the goals are for a zero carbon future, but this is just the tack that Seattle is taking. And coming to the end here, just wanted to kind of highlight that specifically for residential uses, heating, cooking, and water heating, and sometimes clothes drying are the main areas where we do use fossil fuels today, and maybe this would have served us better at the top, but just wanted to talk about when we think about converting technologies in new construction, like these are the main areas that we are focused on. Again, some original research from Rocky Mountain Institute that looks at new construction single-family housing. This report was published in 2018, and I'm actually currently leading the project, the kind of revamp of this project, where we're going to be looking at 7 new cities, both single family and multifamily. So look for that coming out later this year. But basically this shows that for these 4 cities that were chosen for areas of study 2 years ago, the all-electric heat pump approach actually has a better net present cost than the fossil fuel scenarios. And you can see that in the different cities, different fossil fuel scenarios were investigated. So in Providence, which is Rhode Island, New England, very cold, propane and heating oil are some of the dominant sources of heating there. But yeah, we're really looking at natural gas and sort of like the project level or consumer cost trade-offs for adopting heat pumps today. And lastly, just wanted to talk about barriers to commercial adoption of electric buildings. Single family residential is one thing. I think it's quite simple there. That's really a matter of, I think, again, this is a disruptive change to the real estate industry. I think I just looked last night, and as of 2019, the residential single family market, construction market in the U.S. is $1 trillion industry, and I really don't have confidence that that those builders, that those companies will want to or have the capability to transition to all electric technology. So if anybody wants to get into a disruptive market space, I highly recommend looking at all electric solutions for residential buildings. But then when we talk about larger buildings, in the context of urban environments, what are the challenges to adopting electric buildings and new construction today? Basically, 3 main buckets. I mean, regulatorily, decommissioning of the natural gas system for a lot of the world, especially in the continent of the U.S. We really rely on this like natural gas for heating. It's so easy. It's already piped. But if we do want to get to a carbon-free future, we can't have any more natural gas. And so thinking about how those workers, you know, that the fact that it'll take a long time to transition and who gets left behind is really important considerations. And then who ultimately pays for changing the technologies. In the market, I think this is the area where most of us are focused. I'm really concerned about consumer awareness of what even electric buildings are. And this also kind of ties into the contractor risk of folks in the construction industry, you know, not wanting to take on an electric project because they're not really sure, you know, if it can be maintained or warranted. So a lot more work needs to be done in that space. And then a lack of clarity on refrigerant regulation, as we kind of discussed earlier. And then lastly, hugely concerned about equity from the sense that we have to look at energy costs and make sure that that there is a cost control and financing mechanism set up to control for operational costs. Like I mentioned, diminishing service quality for those left behind on fossil fuel infrastructure. And then the notion that how do our policies or our conversions to a new market actually reach renters and low-income communities that don't typically have access to kind of like the latest and greatest market solutions. And I'll just end so we can kind of get to some questions. Hopefully you guys have questions. If we'll take a break. But this is a quote from the head SVP of Sustainability at Kilroy Realty, which is a big developer in the US that may even be international, basically saying there's really no reaction from tenants or buyers for electric buildings. They probably don't know it's electric, they just want a comfortable space. And so I guess this is a question I have for you, like what role do you play in this world of transition? You know, are you a tenant or a buyer that that is unaware, or are you a real estate developer that wants to make sure your product serves your clientele, even though this transition is happening? Like, do they know? And so just kind of want to leave it open-ended and let you know that there's a lot changing, and I'm really curious to hear from you what your questions are and kind of what role you play in this world. You're on mute.
Thank you, Claire, so much. That was fantastic. If you want to stop sharing your screen so that you and I can take the next 6-ish minutes. The good news is that your presentation was so compelling that you have tons of questions. The bad news is, of course, we're not going to be able to get to all of them live, but again, as a reminder to the attendees, all of these questions will be answered and posted on the event website after this day is over. So Claire, there were a couple of themes of questions that came up. I'm going to start with one theme, which is what are your thoughts on how electrification will increase electric load demands and how we manage that? And kind of a subset of that theme is the question about not all sources of electricity being carbon free. And so what are your thoughts on that as well? Oh, you are muted.
Yep, classic. I think there are a couple of different ways to address this. I will say from like what do we really need to change perspective rather than how we band-aid what's happening, is we have to look at how much energy we really need. And I think that we haven't ever had to do that. We're not at all checked into like what does it actually take for us to live a good life. And I think that there is an excess in the energy that we use and the way we regulate our buildings. I know this from, again, working in the real estate industry, like just shocked at how poorly operated most of our buildings are. And so when you think about where we could save, like even before we start to electrify, we have to really be more serious about operations and maintenance and recommissioning of buildings. And I think that is a trend that's coming up in real estate, but I would double down on that if I were the president of the world. And then secondarily, building electrification, I mean, yeah, we have to look at peaking. And in that sense, like this is why hugely concerning when I think about how are the grid commissions working with folks that are leading building electrification and transportation electrification to truly understand what those impacts are. I've seen some pretty cool research that's coming out recently, like for instance, for the state of Rhode Island. I think I mentioned we looked at Providence. Just an electrification study just came out that looks at heating electrification for a very cold climate, and actually looks at grid impacts. And so I would advocate, you know, I don't own any of that particular research, but I would advocate, I can share that in the notes too, that kind of research. And maybe there's also an NREL electrification future study that looked at this too. And so I would advocate for folks in specific areas that this research doesn't address to like work with your governments and research bodies to actually look at this, because like, you know, there's no one answer. It's like, what are the fuel mixes? What are the demands? What are the heating demands of all these different climates? And that will lead us to the answer.
Great, thank you. We do have a couple more minutes. So another major theme that came up, and I know you addressed this somewhat, but it's still just, it's a big question that everyone has. Electrification in cold climates. We had one attendee note that he has seen from some manufacturers in colder climates actual warnings on heat pumps that this might not be applicable, and just other questions about applicability and kind of overcoming the costs and other barriers there.
Yeah, so hugely important that we raise this. I will say that in speaking with manufacturers, and I'll address contractors in a minute, but in speaking with manufacturers, the huge improvements in their technology that have been made in the last 10 years, I think maybe since most folks have kind of checked in on this issue, are that the systems are actually variable speed drives now and tuned in a way such that they can actually provide heating capacity down to -9 degrees F. And so I think as we stand today in 2020, like I'm not talking about 5 years ago, I'm not talking about 10 years ago, I think as we stand today and moving forward, cold climate heat pumps are actually not an issue. Like they have been proven all over the continental US and in Europe to provide cold climates, and it actually comes down to a design. So like, do you want to oversize a heat pump because when we're talking about capacity down to -9 degrees F, it can actually get to, I think, 90% of the fully rated capacity. So like how you want, it becomes a design issue on how you want to trade off oversizing and potentially energy penalties there versus maybe providing an electric resistance coil that just does like the really marginal top up for those, you know, -20 degree F days if you're in Alaska or Minnesota.
All right, that's fantastic. And I'm assuming the technology is gonna, like you said, we're not talking about 5 years ago, we're talking about today. Imagine in 5 years.
Yeah, and I think in 5 years, what we're going to see is just more widespread knowledge on the field experience of these newer variable speed and more finely tuned for cold climates heat pumps. And I think that the risk to contractors will come down through those field verifications, and that's really what I'm putting my money on, what I want to see change.
All right, thank you so much, Claire. So I am going to end this session. I wish we had time to answer all of your wonderful questions, but we will certainly get to them and get those posted. And the next set of sessions is starting right now. So everyone go visit the agenda on the website, choose your next session, and we'll see you on there. Thank you.
Okay, thanks, Erin. Bye.
Bye.